All right, we've been studying circles a lot over the past couple of units, and we're going to look at the idea of a tangent, what a tangent is in relation to a circle. So here's our circle, and this is a tangent line, and what it does is it crosses the circle exactly once. So it barely crosses right here on the edge of the circle. Here's another diagram of a tangent line, and here's the point of tangency where it crosses. And if you were to go ahead and connect that point of tangency with the center, it would create a radius, and it turns out that radius and the line of tangency, the tangent line right here, ends up creating a perpendicular angle or a 90-degree angle. So that's something to know in terms of properties and tangents. Also, there's some other properties here. If we, in this case here, have two tangents, so here's a tangent, crosses here and here. What it's going to do is it's going to first of all create a couple arcs. We have the major arc, which is B. We have the minor arc, which is A. There's two line segments. One of them is M, one of them is N. It turns out a few things are true. First of all, M is congruent to N. So for instance, let's say this distance here was 10 centimeters. Then over here, this must be 10 centimeters as well. So that's one thing, rather obvious, not that exciting, but it's something you should know nonetheless. And there are some other principles here in terms of measurements. So one of them is that if this x over here, this angle here was 40 degrees, it turns out that A ends up being 180 minus x. So if x is 40, 180 minus 40 is 140. So this would end up being 140 degrees from here to here on our minor arc. And the major arc, B, would end up being 180 plus 40. Well, 180 plus 40 is 220. And it all checks because if we take our minor arc and our major arc together here, they add to be 360, which is what should happen here. So let's talk about where this all comes from. So first of all, where does this come from in terms of A? Why is it that A is 180 minus X? So let me go ahead and erase what I have here. So what we're doing here is, let's say we take this point of tangency, and here's our center right here. If we were to connect it with a line and take that and create another radius over here, what we've done is we've created a quadrilateral. Because it's a radius with the point of tangency hitting right there, we're going to create 90-degree angles here and here. And when it's a quadrilateral, all the angles add up to be 360. One angle we already know is 90, and so is another one. So one end is 90, the other one is 90. Then another angle here is x, so I'm going to go ahead and put plus x, and then we have one last angle, which is right here, it's this central angle. And as we know, the measure of the central angle always equals the arc that it intercepts. So if this arc is A degrees, the central angle is also A. Now, if we were to go out and solve here, this is 180. So if we subtract 180 from 360, we get 180 equals x plus a. And then if we went ahead and subtracted x, we would get 180 minus x equals a. So that's where this comes from up here. So I'll put a little check mark there. So let's talk about the second one. Where does this come from, this whole idea of b equals 180 plus x? So what we know is these two arcs, A and B together, must add up to be 360. So I'm going to write A plus B is 360. And as we know over here, we know that A is 180 minus X. So I'm going to go ahead and cross it out. And I'm going to write 180 minus X, that's still B, equals 360. And now if I were to go ahead here, subtract 180, and add x, subtract 180, and add x, it turns out that b would equal 360 minus 180 is 180 degrees plus x. So that's where the second one comes from. Then finally, what happens is that we can go ahead and also decipher that it turns out that x is always going to be the major arc minus the minor arc, whatever that difference is, and then divide by 2. So going back to numbers here, once again, I can really call this whatever I feel like, but let's say I said this is 50 degrees. If that's 50, this must be 130, because that would be 180 minus 50. B would be 180 plus 50, otherwise known as 230. So x is also equal to the major minus the minor. So the major is 230, the minor is 130, and then we divide by 2. Well, what's 230 minus 130? Well, that's 100. And what's 100 divided by 2? Well, that's 50. All right, so this is another thing that's true. So if you knew the arcs, but not what this angle is out here with the two tangents, you can also work backwards and take the major minus the minor and then take that difference and divide by 2. So that's what you need to know about tangents and circles.